Selamat sejahtera. My name is Lim Chao Jie and my matching number is A1XSC0095. Today, I and my team are going to present how to use computer software to solve the problems of control charts for the variables and attribute. The computer software that we choose are R programming and Excel. So for the first question, there is 25 samples of size 50 are chosen from a plastic injection molding machine producing small container. The number of non-conforming containers for each sample is shown in the table below. F is the proportion of non-conforming for each sample. So there is 25 samples, you can see here, and there is number of inspected items 50, the number of non-conforming items, and proportion of non-conforming. So the question requires us to construct a P chart. And the right side is the formula to calculate P bar, upper control limit, and lower control limit, and the formula for revised P chart. So for this question, I use Excel to construct a P chart. Okay, let me show you. Okay, so firstly, I key in all the data into the Excel given by the question. Then I count the P bar, I count the upper control limit, lower control limit. So, okay, so with the P bar, I get a value of 0.072, and upper control limit, I get a value of 0.18167, and this is approximate to 0.182, and the lower control limit is negative 0.0767, which is approximate to negative 0.038. And since the lower control limit is negative, so we can assume it directly equal to 0. Okay, so now I will start to construct the P chart. So in the beginning, I highlight the column of proportion of non-conforming. Okay, center P line, center line P bar, upper control limit, and this column. Assume lower control limit to be 0 since it is negative. Okay, then I click insert, and then I pick this one, insert line or area chart. Okay, now I take this one, slack line with markers, and after I click this, okay, we can see that. Okay, let me show you. Yeah, so in the end, a trial P chart will be produced, but we can observe that the 18 sample is above upper control limit, and I have used another color. Can you see that? If the color is yellow color, yeah, yellow color to represent the point to make it more obvious. Since it is above upper control limit, we can say that the proportion non-conforming is out of control. So this indicates that the process is inconsistent and unpredictable. Hence, an elimination of the 18 sample should be implemented and do the P chart again. So now I do the P chart again. So for the revised P chart, I consult the table again, and I key in all the data given by the question. But this time there is no more 18 sample, and you can see on this table, I eliminate the 18 sample from the table. Yeah. So now you can see that I calculate the bar, upper control limit, lower control limit with the given formula in the beginning. So the value that I get for P bar is 0.066667, which is approximate to 0.067, and upper control limit 0.1725, which is approximate to 0.173, and lower control limit is negative 0.03916, which is approximate to negative 0.039. Okay, so then since the lower control limit is negative, so we can assume it equal to 0 directly. So now, yes, with a similar process, I highlight this column, this column, and highlight this column, and with the same click, insert this one and pick this one, and then you can see that, yeah, a revised P chart will be produced. So in the end, the revised P chart is produced. So from the P chart, you can see that we can observe that all the plotted points are within the upper control limit and lower control limit. Okay, this indicate that the process is consistent and predictable. Okay, so now I will pass the chance to my friend to explain question 2.
So for question 2, we have to construct the NP chart, and I'm using the Microsoft Excel to do it. So basically the NP chart is used for the equal sample size, and it shows the changes of the process over time by measuring the number of non-conforming items produced. So for this question, there is a total of 20 samples with the sample size of 300 each. So before we construct the NP chart, we should calculate the average sample proportion P bar by using this formula, which is the summation of the number of dissatisfied customers divided by the multiplication of the sample size and the total number of samples. So for this question, the P bar we get is 0.0307. And after we get the value of the P bar, we can proceed to calculate the center line for the NP chart, which is also the mean of this data. So we can get the value of the center line by multiply the sample size 300 with the average sample proportion 0.0307, and hence the center line we get is 9.2. And next, we can calculate the upper control limit and the lower control limit by using these two formulas. So the UCL we get is 18.1588 and the LCL is 0.2412. So after obtaining this data, we can get our NP chart here. So from the chart produced, it is very obvious that there is one point has exceeded the value of the upper control limit, which is the 12th sample. So this out of control point is due to some assignable causes. To deal with this situation, we have to eliminate this point and recalculate all the data so that we can construct a new NP chart. So these data are produced after we eliminate the out of control sample. So the total number of samples we have now is only 19. And the sample size remain unchanged. And then we have to repeat the process to calculate all the data here. So our new sample proportion will be 0.0289, and this is the center line, upper control limit, and also the lower control limit. So after we eliminate a sample, our lower control limit will be a negative value. So to construct a NP chart, we have to change the negative value LCL into 0. So this is our new NP chart. So from the chart produced, we can see that all of the points are within the specification limit, and there is no point which is out of control. So from this chart, we can say that the process is stable and in control, and also it is predictable.
Hi, I'm here again to solve question 3. For the third question, the sample of fabric from a textile mold is 100 meters square are selected, and the number of occurrence of foreign metal are recorded. The data for 25 samples are shown in the table below. So from the table, we can see there is the device sample and the non-conformity of the device sample. And the question requires us to construct a C chart for the number of non-conformity. So the right side is the formula for the how to calculate the C bar, the upper control limit and the lower control limit, and the formula for revised C chart. So for this question, I use Excel to solve the problem. Okay, so firstly, I key in all the data given by the question inside the Excel. Okay, and then I calculate C bar, upper control limit, lower control limit with the given formula, and then I get the value of C bar equal to 7.56 and the value of upper control limit equal to 15.808 63625, which is approximate to 15.809, and then the value of lower control limit is negative 0.6xx6 36251, which is approximate to negative 0.6x9. And since the lower control limit is equal to its negative value, so we can assume it to be 0 directly. So now I start to construct the C chart. So firstly, I highlight the column of non-conformity and the bar and the upper control limit and this column. Okay, and then I create inserts. I click this one, insert line or area chart. I pick this one, set line with marker, and then after I click this, there was a trial control C chart will be produced, and from the C chart we can alter that the nice symbol is above upper control limit, and I have used another color to represent the point to let it more obvious. Since the nice symbol is above upper control limit, we consider the process as out of statistical control, inconsistent. Hence, an elimination of nice symbol should be implemented to construct a revised C chart. So now I start to do the revised C chart. So for the revised C chart, I construct the table again, but this time the nice sample is being eliminated. And you can see there is no more nice sample inside the table. So, and then I calculate the C bar, new upper control limit and new lower control limit. And the value of new C bar is 7.20833, which is approximate to 7.208. Upper control limit is 15.2628, which is approximate to 15.263. Negative lower control limit is negative 0.84617, which is approximate to negative 0.846. And since the lower control limit is negative, we can assume it to be 0 directly. So now I start to construct the C charts, and with a similar process, I like these three columns and this column, and then I create inserts. I create this one. Okay, after creating this, a revised C chart will be produced. So in the end, a revised C chart has been produced, and we can observe that all the plotted points are within the upper control limit and lower control limit. This indicates that the process is statistical control and consistent. And next, I will pass the chance to my friend to explain question 4. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Zahiri bin Muhammad Bunangan. Now it's my turn to explain about the control chart of number for non-conformities per unit, or also known as U chart, and I will also explain about how to construct it. Firstly, I want to introduce what is U chart. U chart is an attribute control chart used with data collected in subgroups. There is two types of subgroup size. The first one is variable subgroup size, and the second one is constant subgroup size. U-chart is commonly used to determine if the process is stable and predictable. This chart is very useful when we want to know how many defects of something. Okay, let's go through with the method how to construct this chart. Here we have example from the CC for attribute exercise number 4. Okay, this example is about the variable subgroup size. Okay, there are 20 samples of carpet here, with the amount of carpet inspected for each sample are varies. Okay, then the question is construct a control chart for the number of non-conformities per 100 meter square. Okay, here all the data given. Before that, I will solve this. I will construct this chart using Excel. So firstly, I will transfer all this data to here to the Excel. Okay. Now for U chart, there are four things we need to find. The first one is UI, U bar, also known as center line, upper control limit and lower control limit. Each of these have their own formula. For example, UI we have C over N and so on. Okay, how to find UI? UI is given by Ci over Ni. So here Ci is represented by D. So now we just write equal to D3 over C3 represented for Ni. So then we enter, we get the value here. Okay, for the rest column here, we just drag from this to bottom to get the others values. Okay, now we have the other values. So to make it synchronized, I change all of these into 4 decimal places. Okay, for U bar is we need to find the summation of Ci and the summation of Ni. Okay, so first step, we find first the summation for Ci. Here, just press alternate and plus, we get the sum, the total for Ci, and for Ni, we do the same thing. Drag all here, and we press alternate plus, and we have total for Ni. So after we have both total for Ci and Ni, we can find U bar or center line. Okay, the formula is we take here 192 D23, we log it, and we divide with C23. We also need to log it. Okay, then enter. We've got the answer here. Okay, for the rest value, we just drag here until the bottom. Okay, so now we have all the same U bar because we just use the total of Ci and Ni. Okay, for upper control limit, we have formula U bar plus 3 square root U bar over N. So now we can write the formula F3 is mean our U bar plus 3 multiply with square root in bracket F3 over C3 represented for N1. And then we enter, we get the answer here. Then for the rest, we just drag from top to bottom. And we have the answer for the rest. And also for LCL, we have the formula U bar minus 3 square root U bar over N. So we can write the formula F3 represented our U bar minus 3 multiply with square root in bracket F3 over C3. Enter. Then we have this answer. We drag all for the rest value. So now we have UI, U bar, upper control limit and lower control limit. Now we can select all this data to construct our U chart. Then we find for the line chart. And then we have this type of chart. So this is our U chart. Okay, we need to modify to make it simple to see and to analyze. Okay, then we have chart like here, like this. Okay, so as we can see here, this is 1 point is out of the limit of the control limit. So maybe this happen because when the process some mistake happen. So the solution is we just need to recalculate to ensure all the process are in the process are stable and in control. So the step is we just need to eliminate the data for sample number 7. We drag here. We select all the bottom here. We drag to the top. We bring to the top. And then all of this UI, UBA, and UCL and LCL will change because of the sample here will reduce to 19, and also the summation of CI and NI also will change. Okay, so now we find first the total for the CI. So we just press alternate plus. We have new total for CI and find for total for NI. Alternate plus. Okay. So now for the rest, I have this new value for center line or UBA, UCL, and LCL. Okay. From this, I select all these to construct a new U chart, and the new chart here I get this here like this. So all of this process are in control, and that's all from me. Thank you for watching.
For question 5, we have to construct a control chart for the number of demerits per unit, which is also the capital U chart. So to construct the capital U chart, the non-conformities of the non-conforming item will be classified into different categories with different weights. And this is the benefits of a U chart compared to the other charts, because it doesn't simply sum up the total number of non-conformities, but it considers the weights of the non-conformities. So for this question, the non-conformities are classified into 3 different classes, which is serious, major, and minor, and the weights are 50, 10, and 1 respectively. So these 5 columns are getting from the question given, and we have to make some calculation to get the U chart. So first of all, we have to calculate the total number of demerit D by using this formula. For the first sample, we can get the total number of demerit like this: W1 multiply C1 plus W2 C2 plus W3 C3, so that we can get 92. And the rest will be calculated by using the same method. And then we can calculate the demerit per unit by divide the total number of demerit with the sample size. So for the first sample, we will divide the 92 by 10, so that we can get 9.2, and so on. After this, we can calculate the center line for the U chart. But before we calculate the CL, we have to calculate the average number of the non-conformities first, which is the number of non-conformities is denoted by U bar. To calculate the U bar, we will divide the total number of non-conformities in each classes with the sample size. So for the first class, which is the serious non-conformities, we will divide 9 by 200 and we get 0.045. And the major non-conformities, 74 divided by 200 and we get 0.37. And the last non-conformities is 114 divided by 200 and we get 0.57. After getting the values of the average number of non-conformities in each classes, then only we can calculate the center line for the U chart. So we can calculate the center line by multiply W1 with U1 bar plus W2 U2 bar plus W3 U3 bar. And the center line we get is 6.52. After calculating the center line, we should calculate the standard deviation first before we calculate the upper control limit and lower control limit. So we can calculate the standard deviation by using this formula. And for this question, the standard deviation we get is 3.8739. And then we can calculate the upper and lower control limit by these two formulas. And the UCL we get is 18.1417, and the lower control limit is negative 5.1017. However, to construct the U chart, we have to make the negative value LCL into 0. And finally, this is our U chart. So from the chart given, we can see that all the points are within the specification limit, and the process can be said to be in control.
Assalamualaikum and hi everyone. So today I want to teach you how to do this example 1 in the R programming. So the first step is you take the data from this question to the Excel, which is we have two Excel, and the first Excel is we have out of control, which is we have 25 points, and we know that we already done these questions, and we know that we have 2 points which is out of control. So we must adjust the point, which is we must delete the 13 points and 19 points here. So we move to the second Excel, which is we already deleted 2 points and we have 23 points only. Okay, so this Excel, save it as CSV. Okay, I save it as CSV. So we go to the coding. So we have two coding here, which is coding 1. This is coding 1. Coding 1 for Excel 1 and coding 2 for Excel 2. Okay. For coding 1, the difference from coding 1 and coding 2 is here. Observation and sample. You can follow all the coding here because I got this I get this coding from Google, and I redo this with my knowledge and understanding about this coding, so you can follow this all. Okay, the first thing, the difference between coding 1 and coding 2 is observation and sample. This name, observation, sample. Okay, just these two. Because of what? Because of in the Excel 1 we have observation and sample, and from the observation from the Excel 2 we have data and SAM. Okay, so yeah, something like this. We have observation and sample, and for Excel 2 we have data and sample. For coding 1 we have observation and sample, and for coding 2 we have data and SAM. Okay, don't typo in the any coding here, because if you typo you cannot run the coding. Okay, not that you must follow all this coding here. Okay, so let's start to the R. Okay, we go to the R. How to show the X bar chart? So we go to the file and open script. So the first thing we do is for the out of control first. Okay, so we go to this out of control because this is in control. So out of control first. Okay, we go to the edit and run all. And we choose this out of control Excel, and we see that this is our chart. How to see X bar chart? So we go to this line and we run this. Yeah, and we see that X bar chart here. Okay, this is for out of control. Okay, again, yeah, this is out of control. We have 2 point here, so we must delete 13 point and 19 point. Okay, so we go to the second coding. um we go to the second coding here, which is the same step: file, open script, and we choose this coding, which is in control coding, and we have here data SAM. Okay, so we go to the edit and run all. Okay. Okay, we choose this Excel 2 for in control. Okay, we see this X chart is already in control, and the 2 point we already deleted. Okay, so we have only 23 points here. So how to see the X bar chart? We go to the same line here, this line, so we run it and we get this X bar chart. Okay, okay, that's all from me. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aida Nabila binti Azman, and I will present to you for the control chart for variable. First, we need to use QCC for R. We need to download the package, as package QCC is not in the base. So, after we download the package QCC, we need to call out the package by by writing library and write QCC. So then we can start right away. For the first one is the S chart. We use the name is of SD, and we put all the data in one row. Uh, as as you can see here, and then for the min, you just use the function min, and you put the name, the data name. So here I use data name SD, so we put min SD here, and we can get the answer right away, which is 4.79. Okay, for lower control limit, the formula is B3 times with with the min. So here I write the formula first with the upper control limit formula, which is B4 times with min, and then I call out the lower control limit for the answer, and upper control limit, and get the answer. So and then I can get the answer, the chart for S chart, by writing QCC and the data name, the type of chart, and the limit. So here my limits is lower control limit to upper control limit. And as you can see here, the control chart, the S chart is in control, so we can proceed to do the X bar chart for the chart. Okay, next after we find the S chart, we want to plot the X chart. Like how we do the S chart, first we compile all the data for the mean. So here I the data name I put here X bar. So all the data I list up, and then I find the mean for the X bar. So we can get the X double bar. So the answer is 37.175. Okay, and then for lower control limit for the X bar, the formula is min X bar minus with B3 times with min SD that we get just now. So for the upper control limit, and the formula is min X bar plus with A3 times with min SD that we get just now. So I call out the lower control limit to get the answer, and call out the upper control limit for the answer. And then for the chart, we use the same formula as just now. So just mention QCC, and in the bracket, put the data name, the type, and the limit. And then we can get the chart, the X chart, like here, like this one. As we get the X chart, we can see that the chart is in control, as there's no data that more than the limit. Every data is in the limit of the lower control limit and the upper control limit. So we don't have to adjust the data, as the data is already in control. That's all from me. Thank you.